So the new name that the WHO has given the virus is called SARS-CoV-2, and the disease that it causes is being known as COVID-19. This is the virus, this is the disease. This case is outside of China. Now they start looking at total cases excluding mainland China. And in terms of those cases, we are not seeing a leveling off, but more of still this epidemic. So it looks as though things are still taking off outside of China. When we look at cases per day, we can see here that just in the last couple of days, we've had the most number of cases outside of China being diagnosed. I want to talk a little bit about the viral infection itself and immunity. For that, we're going to draw out a little bit of a schematic here on how this happens. So the first thing that happens is, of course, you have this virus particle, which we'll draw as stars. And these stars are outside the body. So this could be an airway, this could be inside the GI tract. So this virus goes in and latches on to cells, receptors, and it causes these cells to become infected with the virus. And of course, the virus takes over the machinery of the cells, and it causes it to make more of it and proteins. And so these cells will be coated with these proteins on the outside. And of course, more particles are made, these cells explode, and they release more and more of these virus particles. Here on the blood side, you've got things called cells, which are blood cells, and one of those cells is called an antigen-presenting cell. And so these cells start to go in and extravasate from the blood into the tissue, and they're able to recognize these cells that are abnormal because of these abnormal proteins on the surface. So these antigen-presenting cells envelop and destroy these virally infected cells. So let's show a little bit more of a close-up of how that happens. So we have this antigen-presenting cell, and inside the antigen-presenting cell is the cell that is infected with virus, and it's got virus particles on it. And so what's very important what this antigen-presenting cell does is it presents the antigen. So here is the antigen presented on the outside of that cell. This is the most important thing that the antigen-presenting cell can do, because what it then does is it meets up with something called a Th1 response, or a CD4 positive cell. And this cell here is the mastermind behind your cellular-mediated immunity, because this antigen here will latch on to this CD4 positive Th1 cell, and it will release IL-12, which is a chemical that comes from the antigen-presenting cell that stimulates this cell to go and fight anything that looks like this on it, that antigen. And so there's major responses that can occur. Number one is that these Th1 CD4 cells will then stimulate another type of T cell called the CD8 cells, and those are killer cells. And they go out, and all they do, they will kill any cell that has those antigens on it. The way that that happens is it has little proteins on the surface that will recognize this and cause docking to occur. So you want that connection to be very, very tight. Another thing that this Th1 can do is it can stimulate in the blood and tissue B cells, and these B cells will produce antibodies that look like this, and these antibodies will bind to these antigens and neutralize them. So this really is immunity. And this is the key that allows you to survive a viral infection. This is what determines whether or not you get admitted to the floor or whether or not you go to the intensive care unit. Because if this reaction doesn't occur correctly and this immunity doesn't get on top of the viruses quickly and limit them, kind of quarantining this, then you get wide viral infections all over the body, and the amount of infection causes more immunity, which causes more inflammation, and that's why people die. If you do get coronavirus, you want your immune system working perfectly. And wouldn't it be nice if there was something that we could do to enhance this IL-12 response, to enhance the ability of this binding to occur, to enhance the ability of CD8 killer cells to bind their targets and to destroy, to enhance the ability of Th1 CD4 cells to create and stimulate actually these B cells to make antibodies? Well, there actually is something that we can do that can enhance this. Number one, it's not a drug. Number two, it's absolutely free. There's no money involved. Number three, you can do it anywhere. And the answer is sleep. And enough of it greatly enhances the ability of the antigen-presenting cell binding to the Th1 and promoting IL-12. Sleep also prevents the breaking up of this binding site with CD8 killer cells with the antigen. Sleep has a tremendous effect on your immune response against viruses. And the patients were sleeping because these hormones were at very low levels that prevented the inhibition of this G protein, which caused better binding and more effective killing of these infected cells. At the beginning of the night, when you go to sleep, normally, let's say around 10 p.m., the first thing that occurs is that you should be having more slow wave sleep at the beginning of the night, and towards the end of the night, more REM sleep. Well, they're starting to see that slow wave sleep is integral in the production of growth hormone, and growth hormone has tremendous effects on immunity. And the secretion of IL-12, which is what we recall is the thing that causes the antigen-presenting cell to stimulate the Th1 response with the CD4 cells. So that's tied to slow wave sleep. This is the sleep right here that occurs, generally speaking, between 10 p.m. and 1 a.m. in the morning. And this is the sleep that we cut off the most by going to bed late. And so we're losing out on growth hormone, and our immunity stinks because of it.